right, go and take your textbooks out if you would. Please turn to page 445. Page 445. I want you to do a quick review with factorials and permutations. We had some of this in the homework the other night. I had a little bit of difficulty with it, so by way of review, page 445, the review 10 through 17. Page 445, the review numbers 10 through 17. Take about, 4 or 5 minutes maybe to work on this, and then we'll take a look at it together. let's go ahead and take a look at these together, even if you're not finished. Number 10, Lana, we're going to give you first shot at this. We didn't have a review exercise today, so we'll make this worth the candy today. Number 10, what did you get for 5 factorial?
120.
120. Number 11?
6.
6. And number 12?
720.
720. We might have that one memorized. We've seen 6 factorials so many times. I know Scott had mentioned at one point he did. Not sure if that was still memorized for you or not. What about number 13? A permutation of 15 taken 2 at a time?
210.
210. What about number 14?
3024.
3024. And then number 15?
720.
Also 720. It's basically the same as number 12, except the times 1 at the end, which by the time you've taken 5 out of 6, the last one's predetermined anyway. You might as well have taken 6 out of 6. Number 16, bag contains 5 marbles, a purple, an orange, a pink, a turquoise, and a cyan, which is almost the same color as turquoise. In how many possible orders could the marbles be pulled from the bag, one at a time?
120.
120, and realize it's really the same as number 10, right? That's basically 5 factorial. Number 17, teacher needs 3 volunteers from his class, 1 for each of the different after-school tasks. His class has 22 students. How many different possibilities are there? Lana, we're essentially setting up what? Of taken 3 at a time. Good. Permutation of 22, taken 3 at a time. And your answer was?
9,240.
9,240 is correct. Joshua, did you get all the ones you did correct?
I did all of them, but
Which one were ones?
the last one,
Okay.
I had the correct setup and everything. I just put 8 plus 1 equals 10.
I'm sorry?
I said I had the right setup and everything, except that I put 8 plus 1 equals 10. I don't know.
Oh, okay, so just an addition error when you multiply, because you have 22 times 21 times 20, right? And then so somehow with it, when you do it, adding the partial products together, just an addition error. All right, questions on that? All right, go ahead and turn over now to page 449. Page 449, and yesterday we began looking at a type of, like a bar graph, but it was not so much to deal with numbers of things individually, but rather the number of items within a certain range of values, how frequently these ranges of values would come up. And what type of graph is that, Joshua? The histogram, right? And the histogram, again, deals with ranges, much like right before it, we talked about just kind of a list of all the different numbers that fell within different ranges, and that was something we called a stem and leaf plot. So both of them are kind of group things into categories, right? Your 20s, your 30s, your 40s, and so forth. Well, here on page 449, we have a histogram that shows how many books that students did their book reports on. How many students had books that were within the 100-page range, 200-page range, 300-page range, and then really, really big books. Now, y'all aren't allowed to do 100-page books, right? What's the minimum number of pages for your book reports?
Like 150.
150. Oh, well, that would still be in the 100, 200 range, I guess. So, anyway, how many? Let's just look at the graph for a moment and answer these questions. It says, how many units do the minor grid lines represent? How many units is each minor grid line?
1.
Just 1, right? Because there's a gap of 4 between the major, and there's the 3 other grid lines in between. Which class has the most books, Joshua?
The 100 to 200.
Right, the 100 to 200, we call it the hundreds class, right? Because once you get to 199, that would be the last book. As soon as you get 200, you're technically entering the next category. So the 100 to 199 are the hundreds class. Which group, what size books, what length of books did 6 people read for their book reports? Lana?
None. Well, like.
There were 6 people who read a book that was in the 300 class, right? The 300 to 399 class, if you will. How many more books are in the hundreds class than the 200s class, Joshua? Obviously, most of the class wanted to read the little shorties, but how many more read the little shorties than the next size up? 6. Good, 6 more. And then how many students read a book that was less than 400 pages? And Lana, give us that answer once you've got it. How many students stayed under 400 pages on their books?
Wait. Percent or number?
Number. How many?
Oh.
Like actual? Yeah.
28.
Good, 28. How many total people in the class? It doesn't ask this, but Lana mentioned percent. We'd have to know the total number of people to get that. How many total people in the class?
16. Wait. No. 24? No.
Well, how many people read a book from, assuming everybody had to read a book, right? It's not like, well, you know what, we like Lana, so you don't have to do a book report. No, everybody's doing the book report book, right? So some people, 14 people read 100-page books. What?
31.
I've just got 30 here. I got 14, 8, 6, and 2, right? Would be the lengths of each of those. So you just add those together. That doesn't, that is 30, right? All right, 14 plus 8 plus 6 plus 2. There's 20, there's 10, that's 30.
Yeah.
There we go. Yep.
I forgot to add the 2 at the bottom.
Ah, okay. All right, questions on that? Again, just some different things that you can work with histograms, some different questions we can answer. Of course, if we wanted percentages, Lana, I wouldn't want to use a histogram. If I wanted percentages, I would have used a circle graph. But the histogram allows me to show not percentages, but actual frequency within various groups. Number 2, a fitness club encouraged its members to record their caloric intake daily. Wow. Okay. And note, they give you all these huge numbers, right? Well, we're going to break these down into categories. And notice at the very end, it gives you in parentheses how we want the categories to form. We want our groups in groups of 400. So let's do 1200 to 1600. Then the next would be 1600 to 2000. What would the next group be, class? 2000 to
2400.
2400. Then 2400 to 2800. Is anybody over 2800?
Yes.
So we need one more group. So we'll say
2800 to 3200.
There we go. Okay, so we've got these different categories here. Let's figure out how many people are in each group. Okay, so the number in each group. How many people, count them up, were between 1200 and 1600? How many people, when they recorded their daily calories, okay, 3 people said they stayed between 1200 and 1600 calories. That's like one meal. 1600 to 2000.
5?
Is it 5 or is it 6? What do we do with 2000? Does 2000 go in this category or does 2000 go in the next category?
The next.
You always go to the next category if you hit the end. So technically it'd be 1999, but we say 2000, right? So it would be 5 because the 2000 actually goes to the next category. Does that make sense? All right, that's one of the reasons why we're practicing this, by the way, was to emphasize that point. All right, so how many in the 2002? Technically 2,399, but we say 2,400.
6.
6, good. Not that 7. That 2,400 goes in the next category. All right, how many in the 2,400 to 2,800?
3? No,
4.
4.
Yeah.
And then the 2,800 to 3,200?
3.
3.
3.
There's the 28, the 29, and the 30/50.
Oh.
Right? All right, so let's go ahead, maybe get out some, if you have graph paper, that might be even easier, but otherwise just get out some regular paper, and we're going to need to make how many vertical bars here?
5.
5, 1 for each of the 5 classes. So there's going to be a space for 1 bar, 2 bar, 3 bar, 4 bars, 5 bars, and I'm going to erase off the little bit of extra there. So I've got my 1200 to 1600 to 2000, 2400, 2800, and 3200. And this is the daily calories. And we'll go and put that axis title on those. There, we obviously have the labels going here. And then we need to have our scale. And the biggest number that we see is going to be the number 6. So should my biggest number on my scale be 6? No, because we don't want to hit the top of the graph. Maybe my biggest number should be
7.
7's kind of an odd number though. Let's go with 8, right? Because 7, like, how do you break that down? Let's go with 8. So let's set the top of my graph at 8. And then halfway across will be 4, right? And then let's go ahead and go halfway in between there and say 2. Halfway in between there, we'll say 6. And then we could even put, if we wanted to, we could put kind of a lightly drawn minor grid line through the middle of each of these segments. Okay, so something like that. We did forget our chart title. Number of members would be my axis title here. Let me slide this out of the way. We'll, I don't know, is it health club? Fitness club. Fitness club faithfulness. Hey, you didn't want to be faithful, shouldn't have joined the fitness club. All right, fitness club faithfulness. Here we go. All right. And my first bar should go up to
The
3, because there's 3 people.
Yeah.
Oh, don't overcomplicate this now. This is really easy, at least it's supposed to be. And remember, for shading, I just kind of do a scribble shade, being careful not to go outside the lines. You don't even have to fill all the way in, just don't go outside the lines. The next bar needs to go up to
5.
5. But in a histogram, remember, we are not going to leave any gaps. So, going right up against it. Because where the 1600 calories leaves off, the next one picks up. Where the 1599 leaves off, the 1600 picks up. The next bar goes up to 6. Just a little bit higher. And the next bar, 4. And the last bar, 3 again. And this is really pretty even, isn't it? I mean, whereas with the book reports, like, it was way front heavy, right? Like, way people did barely any pages. And then you get to the bigger books, it's obviously understandably going to be fewer people. This is really pretty even, isn't it? So probably the normal person, you just look at it, was in between 2,000 and 2,400 calories a day. No outliers or weirdness at all here. It's nice, even, steady distribution. You'd expect your mean, your median. We don't know about the mode because we have a small sample size, but mean and median for sure are going to be right around the same number. So, yeah. Questions on how to make a histogram? Any questions on this? All right, turn over to page 250, or 450, excuse me. Turn to page 450. Now, you are not going to be tested on scatter plots, but I did want to point these out because you'll see these from time to time. Standardized testing will ask about these. I just wanted to point out some different things to you. A scatter plot is literally a dot plot for various data. So you see here the rebounds per game. They point about, okay, people that are this tall get this many rebounds. And so they put a dot for every person's height who had rebounds. And there's your dots. Do you see that a 65-inch tall person got 4 rebounds a game? You see that? There's a dot there. The 75-inch person got 6 rebounds. Actually, technically, I guess that 74-inch person got 6 rebounds, right? Which heights got the most rebounds?
77.
It looks like 77 and 73, maybe?
Yeah.
Yeah, but you see it's just a dot, right? Now, there's a couple terms I want to point out to you. Again, not for testing purposes, just so you understand them. Association. If dots tend to form a pattern, we have what's called association. So if you're looking at a scatter plot, there's absolutely no association here. These values are just everywhere. But if the dots are all here, we know it's a pretty level, consistent value where there's really not much of a change. Like everything here is getting the same values here. But if the values progressively all seem to be clustered, they all get bigger and bigger together, we would say we have what's called a positive association, meaning as this gets bigger, that gets bigger. They're both going up. We kind of see that with the rebounds, don't we? Now, it's not real strong, but we do kind of see a pattern where the dots kind of keep going up, which makes sense. Tall people, more rebounds, makes pretty good sense to us, right? A really strong association is have a lot of dots close together going upward. That'd be a strong positive association. If there's a few dots here and there kind of going upward, that would be a weak positive association. Do you see that there on the association? The difference between strong positive and weak positive. Now, it's possible, though, if we wanted to talk about, maybe again, if we're talking about basketball, assists per game. Tall people generally aren't getting, I mean, there are some who are very good with the basketball, get a lot of assists, but generally, when the tall person gets the ball, he's down low and he's shooting, right? So, and he's usually making the bucket. So maybe if we did like height and assists, the taller the person gets, the fewer assists. Did you hear that? Let me say it again. The taller they are, the fewer assists, maybe. Well, do you notice those are going different directions? As the height goes up, the number of assists would go down, for instance. Well, that's what's called a negative association because they're going in opposite directions. Well, that's what you would see there if it looks like the graph is starting to go down. That would be a negative association. Again, strong negative, all the dots are really close. Weak negative, they're kind of spread out. They're still going down. You can still kind of see the downwardness, but it's kind of spread out going down. And of course, no association would be, there's just the randomness, as we talked about. You can sometimes on a scatter plot see clustering as well. Look across the page, and you notice that we've got, it almost looks like two little, of like almost like if you took the spray paint can or something, and they just kind of just sprayed a little bit of stuff and a little bit of stuff. There's dots all over here, and there's dots all over there. It's not so much really truly an association, because there's a gap between them. Do you see it? They're on page 451. So clustering sometimes happens as well. An outlier would be a point that doesn't fit in a cluster. For instance, you're looking at wolf weight versus distance traveled. Look at your 120-pound wolf. Only one of the 120-pound wolves traveled 7 miles. But that little dot's all by its lonesome. It's not in the cluster. One could almost make the argument that the 140-pound-ish wolf, 14 miles, is a little bit away from its cluster, but not too bad. But there's definitely that one dot that's just kind of by itself. Well, again, that's an outlier. A dot that doesn't fit in with the others, an outlier. It also talks about trend lines, how you can try to kind of figure out what's a pattern that kind of goes with all the dots. So you see that idea with trend lines, and sometimes a trend line has to be curved, sometimes it's a straight line. We're not going to get into all of that, but again, you can kind of see, okay, it's kind of dropping down or it's kind of going up. And that's kind of visually what we would think. And of course, businesses would use these scatter plots to predict what may be following in the future if they continue to increase or decrease certain things. If you were to look down to page 453, look at number 3. Would you say that that's a negative or a positive association? Yeah, number 3 is definitely going down. Would it be fairly strong or would it be fairly weak?
Strong.
It looks pretty strong. Those dots are pretty much all headed down. Look at number 4. Would you say that's positive or negative?
I'd say positive.
Kind of positive-ish, but it's really hard to tell, isn't it? I mean, the points are kind of everywhere. It kind of is getting higher as you go further along the graph, right? But it's very, very weak, right? Look at number 5. Would you say that's going up or down?
Down.
Kind of down-ish, right? Well, okay, I just now saw the last dot. That is really far down. So yeah, definitely going down, but again, it's very weak negative association, right? What about number 6? How would we describe that?
Negative.
It's positive.
Number 6? Number 6 is going up.
Yeah.
Yeah, number 6 is going up, and it's going up pretty quickly too. Pretty strong, pretty tight. model going up. So we'd say strong positive association. Things like that are the types of things that you'll be asked maybe on standardized testing. So I want to point those out to you, but you're not going to be tested on those. Turn down to page 200 or 400. Keep doing that. 464. Page 464. I want you to take the next several minutes now to work on some problems here. We're going to practice with some stem and leaf plots and practice with another couple of histograms. Page 464 to 465, doing numbers 20 through 25. Pages 464 to 465, doing numbers 20 through 25. Again, scatter plots, histograms, they're the two that group the data into, well, that boil the data down into groups as opposed to individual data values. Allows us to make determinances from the data based on those groups. And Scott, I just realized I didn't catch a whole lot of that graphing with the dot stuff on the screen. Sorry about that. And they were nice enough on 20 to rank the data for you. Number 21. Nope. You can rank it yourself, or you can try to just check it off as you go. Your call.
Number 23A, are we supposed to actually find the median or just do it by just trying to look at it?
23A. I'm a big just kind of guesstimate. Just make a guess because I'm curious what your guess is. The point of this, again, in my mind, if I told you find me the median, obviously you could check stuff off and find it easily enough. I'm curious, can you guess, can you figure what it must be just from kind of looking at, okay, this many data values, this many data values, this looks like it's kind of in the middle of all the data values. But you could actually calculate if you wanted to. For sake of time, we're going to need to go ahead and stop where we're at. I don't think either of you had time to get to number 25. That's okay. We'll go up through 24. Check your work. On 20 and 21, finishing the stem and leaf plots. Should have finished the 4 stem with leaves of 0, 2, 5, and 8. The 5 with 1, 3, and 7. And the 6 was 0, 2, and 3. Check to make sure you have 10 values, and you do. For number 21, should have finished the 10 leaf, or the hundreds stem, excuse me, with leaves of 2 and 3. The 110 stem, or the 11, finished with a 9, the 12, finished with a 0, 1, 5, and 8, the 13 with a 1, 6, and 9, and the 14 with a 2. Good to go on making the stem and leaf plots, I assume. Number 22, let's see, letter A. What range of values is represented by the stem 13? What range of values is that 13 supposed to represent, class?
130s.
130 all the way up to 139, right? The 130s range, right? And how many students have a height in that range?
None.
Nobody. All right, what's the height of the tallest student, Joshua?
158 centimeters.
Good, 158 centimeters. I don't know that I'd call him an outlier, but he's taller than everybody else. Letter C says, is there an outlier? They would say yes, he's an outlier because he's 14 centimeters taller than everyone else. I don't know, whatever. To me, you know, if you were like 168 and there were nobody in the 150s class, I'd say he was more of an outlier, but they call him. What's the mode? 124 centimeters is your mode. We've got a few heights represented 3 times, but that one has represented 4 times. Number 23, Joshua, you asked about this. Did you find the median for the data?
I didn't actually do it, but I looked at it.
Okay, what did you get?
I got 32.
32 is the actual exact median, in fact. Yep.
I thought it was 45.
Well, the thing is, Lana, there's a whole bunch of data at the top and there's very little at the bottom. In fact, if you look just at the top 2 rows, Lana, there's as much data in those 2 rows. In fact, there's more data in those 2 rows than there are in the 4, 5, 6, and 7 combined. So we actually need to be looking in the middle of the 3 or even shift toward the front of the 3. So I would have guessed 33 for my median. It is in fact 32, but if I were guessing, I would have said 33. Good job on that, Joshua. How many people did fewer than 20 sit-ups? Fewer than 20, Lana? 7. Is there an outlier, and if so, what is it, Joshua?
Yes.
Yes, so
75.
That's a very clear outlier. Okay, and what's the mode of the data, Lana? 33. Questions on that?
Number 22C.
Yes.
I put no, so it's
I'm inclined to say no. The book says yes. I'm inclined to say no. I mean, you're 14 points off another data point, but from 129 to 140 is 11-point difference. How is 14 that much more than 11? I don't say it's an outlier. Again, significantly further away than anything else. There's already a big gap of 11 in there, and we got lots more data after it. So no, to me, there's not an outlier. The book says yes. We can agree to disagree, I suppose. Number 24, service time in drive-through. All right. What does the vertical scale represent? Don't make this hard, Lana.
Number of customers.
Very good. Number of customers. What does the horizontal scale represent, Joshua?
time in minutes.
Time in minutes. Very good. How many customers waited 4 or more minutes, Lana?
23.
23. Very good. There were 17. Yeah, 17 who waited 4 to 6. There were 5 that waited 6 to 8, and then 1 customer that waited 8 to 10 minutes in the drive. That's a long time to be in a drive-through, by the way. I've been in a drive-through once that was like 10 minutes long, and I'm like, this is ridiculous. The whole reason I went in the drive-through was so I wouldn't have to wait, because I'm an impatient American. How many customers waited fewer than 4 minutes, or less time than 4 minutes, Joshua?
I didn't do that.
Let's say I got 28 in the 2 to 4, and I got, is that 5 in the 0 to 2? Yeah, so 28 and 5 would be 33. And then how many total customers in the histogram? Did you get that far, Lana?
66.
Not 66, careful on your addition, 56. 56, you carried 1 too many over to your tens column. Okay, you've got a 5, you've got a 28, you've got a 17, you've got a 5, and you've got a 2. Okay, that's, wait a second, I must be misreading something. I got 2 5s. Oh, that's a 1, not a 2. Okay, never mind. So I got a 10. I'm going to add these two to get 18. And so we add this 16. 1, 2, 1, 1 is 5.
Oh.
All right, questions on that? Clear your desk except for a clean sheet of paper and a pencil. Clean sheet of paper and a pencil. Everything else off your desks. This will be your last quiz of the quarter. Last quiz of the quarter. We'll begin exam review tomorrow. I want to take one last quiz, taking quiz 33. So desks cleared except for a clean sheet of paper and a pencil. I will write the homework on the chalkboard. So Scott, if you would pause the video once I've written the homework up there, maybe pause the video to take the quiz and then play the video back long enough to get the homework off the chalkboard. Paper, pencil, that's it. Let's go. All right, first and last name and the name spot. Today's date, the date spot. Today is 3/11/21. 3/11/21. 21, today's date. Pretty straightforward. You've got a graph type thing, okay? 5 questions. Another graph type thing. 5 more questions. Answer the questions. That's it. Again, homework will be on the chalkboard.